now we will understand how metals react with non-metals. For this we should know octet rule. Octet rule was given by G. N. Lewis and W. Cosell. According to this rule, an atom whose outermost shell contains 8 electrons or octet is stable. So any atom which contains 8 electrons in its outermost shell is stable. This rule, however, does not hold good in case of certain small atoms like helium. In which presence of 2 electrons, that is duplet, in the outermost shell is considered to be the condition of stability. Examples of elements whose atoms have fully filled or 8 electrons in their outermost shell are neon, whose atomic number is 10, electronic configuration 2, 8, argon, atomic number 18, configuration 2, 8, 8, krypton, atomic number 36, configuration 2, 8, 18, 8. So all these elements contain 8 electrons in their outermost shell. These elements are noble gases. Thus all noble gases contain 8 valence electrons except for helium, which contains 2 electrons in its outermost shell, and all the noble gases are stable. They do not usually form bonds with the other elements. Atoms combine with one another to achieve noble gas electron configuration and become stable. So every atom tries to be stable. How? By achieving noble gas configuration. That is, by acquiring 8 electrons in their valence shell. For this, atoms form chemical bonds. To achieve stability by acquiring the inert gas configuration or by completing their octet or duplet in case of small atoms. An atom can achieve the inert gas electron arrangement in three ways. That is, an atom can become stable in three ways. One, by losing one or more electrons. Two, by gaining one or more electrons. And three, by sharing one or more electrons. Thus, in order to become stable, atom may lose electron, gain electron, or share electron with the other atoms. We will now focus on the concept of ionic bond. This bond is also called electrovalent bond. So ionic bond is also called electrovalent bond, which is formed by the atoms of electropositive and electronegative elements. Electropositive elements lose electrons in a chemical reaction, while electronegative elements gain electron in a chemical reaction. When an atom of electropositive element come in contact with that of an electronegative element, then the electropositive element lose electron and becomes positively charged, while the electronegative element gain electron and become negatively charged. Electrostatic force of attraction works between the positively and negatively charged ions, due to which both ions get bonded together. As a result, a chemical bond is produced between the ions, which is known as ionic or electrovalent bond, and the compound formed is known as ionic or electrovalent compound. Thus, the bond formed between ions is called ionic or electrovalent bond. And the compound thus formed is called ionic or electrovalent compound. Number of electrons number of electrons donated or accepted by any element is called electrovalency. In an ionic compound, every cation, that is positively charged ion, is surrounded by a fixed number of anions, that is negatively charged ion, and every anion is surrounded by a fixed number of cations, and they are bonded in a fixed geometry in a three-dimensional structure. So, in an ionic compound, every cation is surrounded by a fixed number of negatively charged ion. Similarly, an anion is surrounded by a fixed number of positively charged ion. And anion and cation both are arranged in a fixed geometry. Let us now take an example of ionic compound. A very commonly used ionic compound is sodium chloride. Sodium atom, which is electropositive in nature, being a metal, loses an electron from its outermost orbit and gets converted into a cation to attain noble gas configuration. Thus, sodium, whose atomic number is 11, configuration is 281, it has one valence electron. It loses electron to become Na plus, whose configuration now becomes 28, which is that of noble gas. Energy required for this process is called ionization energy. So sodium atom acquires ionization energy to form Na plus by giving out an electron. Chlorine atom, which is an electronegative element, accepts the electron donated by sodium atom in its outermost orbit and forms chloride ion. So chlorine, atomic number 17, configuration 287. It has 7 electrons in its outermost shell, and in order to become stable, it gains one more electron, converts into chloride ion, whose configuration is 288. In this process, energy is released, and this energy released is called electron affinity. Due to the opposite charges on Na plus and Cl negative ions, they are bonded by electrostatic force of attraction to form NaCl compound. Here electrovalency of sodium and chlorine both is 1 because sodium loses one electron which is gained by chlorine to form chloride ion. For the formation of an ionic bond, it is necessary that the ionization energy, that is also written as IE, of electropositive element should be less and the electron affinity, which is written as EA, should be high. These two are the favorable conditions for the formation of ionic bond, that is, the ionization energy of electropositive element should be should be less, and the electron affinity of electronegative element should be high.